everyone. So today we will study the whole chapter. The first is chemical reaction. So what do you mean by chemical reaction? So here is the definition. Chemical reaction is the process by which one or more substances react with each other to form new substances with different properties. We represent a chemical reaction as A plus B gives us C, where this A and B are called reactants and C is called the product. Okay, so this A and B, this together, they are called as reactant, and this C, the C that you are seeing, I am representing it as a product. So let's consider an example. That is, carbon is considered as A, okay, and B is oxygen and C is carbon dioxide. So we write a chemical equation as carbon plus oxygen gives us carbon dioxide. So next let's go for chemical equation. So what is chemical equation? So chemical equation is nothing but the chemical reaction that is taking place, okay? So the definition is that chemical equation is the symbolic representation of a chemical reaction in the form of formulas and symbols. So the chemical reaction where we use formulas, okay, or symbols. So here I am showing an example, that is C plus O2. C is the formula of carbon. O2 is diatomic oxygen and CO2 is carbon dioxide. So make it clear that in chemical equation we will not write the names of the element or the name of the compound. We will only write it in symbols and formulas. Okay, so next we have two reactions, that are the reactions involving energy, endothermic and exothermic reactions. These are the two types of reactions which are involving energy. What do you mean by endothermic reactions? Endothermic reactions are the reactions in which energy is absorbed or energy is supplied, okay, in the form of heat, sunlight and electricity. We can say that this type of reaction, it involves energy and energy is supplied to these type of reactions. In these type of reactions, it takes place by absorbing energy. Okay, here I'm showing you, like I'm showing you, suppose this is the reaction is going on here and heat is being uh, given, supplied from outside, okay, from the surrounding the heat is supplied. So this reaction we will call it as endothermic reaction, since heat is supplied. Okay, first example that I have shown here, example number 1 is of photosynthesis. Okay, so in photosynthesis, plants take heat from the sun through their leaves. That energy, along with water H2O and carbon dioxide CO2, is converted to food. So that energy is taken. Okay, so that energy word is used here. So without absorption, this is not possible. Is this possible? Without absorption, if the plants doesn't take heat from the sun, will it be possible? No, plants take the heat from the sun, so it absorbs, energy is supplied. Okay, next example is melting of ice cubes. So if we add ice cubes in our drink, then we will see that the ice cube pulls the heat from the water to melt itself. So the ice cube will absorb the heat from the water. So this example is also a proper example of endothermic reaction, because it absorbs energy from the surrounding. Exothermic reaction in which heat is released with the formation of product, are called exothermic reactions. So heat will be released. So this is an example of burning of natural gas. This is methane plus 2O2 gives us CO2 plus 2H2O plus heat. So this heat in this reaction, okay, in this reaction, this heat is released, isn't it? So in this reaction the heat is released, so this is called an exothermic reaction. So now we will study about the types of chemical reaction. Okay, there are four types of chemical reaction. Okay, we have four types of chemical reaction. First is combination reaction, second is decomposition reaction, third is displacement reaction, and fourth is double displacement reaction. So we will study this I will explain you all these. Okay, so first is combination reaction, a reaction in which two or more reactants combines to form a single product is called combination reaction. Okay, so combination reaction means when a reactant, so this is one reactant, this is another reactant, it is combining and is forming calcium hydroxide plus heat. So these are the reactants. Okay, these are the reactants. So these two are the reactants and they are giving a product. Okay, this is the product. So which means that calcium hydroxide and water combines. Calcium hydroxide, this is calcium hydroxide, this is water, form the single product, one product. These two are combining and they are forming one product. So now, and it will give calcium hydroxide. So calcium hydroxide, it is named as agline, which is used for whitewashing of walls. Okay. So let's see some more examples of this reaction. Some more examples are burning of coal. So carbon solid form plus oxygen in the gaseous form gives us carbon dioxide in the gaseous form. Okay, so how are these examples? These are the two reactants. Okay, two reactants will give us a single product. The two reactants will give us single product. So next is formation of water. So hydrogen diatomic form in gaseous form and oxygen diatomic form gaseous form gives us H2O, that is water in the liquid form. Okay, these are also the two reactants, hydrogen and oxygen, they are forming one product. So these are called combination reactions. These are combining and forming one product. Okay, these two are combining and they are forming one product. Means you can write as these two combines. These two combines and they are forming this product. So this is called combination reaction. Second type of chemical reaction is decomposition reaction. So decomposition reaction is one in which a single reactant breaks down to give two or more simpler substances. So the first example that I have shown is 2FeSO4, that is one single reactant. When it is heated, it gives Fe2O3 plus SO2 plus SO3. So one reactant breaks into three products. Okay, so three products we are getting here. So ferrous sulfate gives us ferric oxide plus sulfur dioxide plus sulfur trioxide. This kind of reaction is called decomposition reaction. The second example is calcium carbonate. So calcium carbonate, when it is heated, okay, it gives us calcium oxide plus CO2. So calcium CO2 is carbon dioxide. So the full form of CO2 is carbon dioxide. Now these reactant is giving us two products. Okay, CaCO3 is giving us two products. So CaCO3 is limestone. So this is the reactant, it is giving us two products, and so it is a decomposition reaction. Okay, so always remember that when a single reactant, it will break down to give two products, it is called decomposition reaction. So here we are getting 2 products and there we are getting 3 products. So now you see one more thing here. In 2FeSO4 it is heated and then we are getting the product. So when it is heated, when a decomposition reaction is carried out by heating, then it is called as thermal decomposition. Okay, definition is like when a decomposition reaction is carried out by heating, it is called thermal decomposition. This is the simple example. These are the 2 simple examples, and these shows that these are thermal decomposition. So next type of reaction is displacement reaction. So displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. So more reactive elements will displace a less reactive element. So this is an example of an activity, okay? So it says that if we take 2 test tubes and in each test tube we put 10 ml of copper sulfate solution, then tie 2 iron nails in one of the test tube with a thread and keep it for 20 minutes. Okay, also keep one nail aside for comparison. After 20 minutes, take out the iron nail from the solution. Then we see that the iron nail becomes brownish in color and the blue color of copper sulfate solution fades because iron has removed copper from the copper sulfate solution. Okay, so now this is the small activity from the book. I'll show you that this is a test tube, but we have to take 2 test tubes like this as given in the activity. We will take 2 test tubes and fill it with copper sulfate solution and put it in a stand. So first what we will do, we will take in each test tube we will put 10 ml of copper sulfate solution. So here we have 10 ml of copper sulfate solution in this test tube. Okay, and we have dipped 2 iron nails, clean iron nails we have dipped here. Tie 2 iron nails in one of the test tube with a thread. So we are tying 2 iron nails here with a thread. These are the iron nails and they are clean. Okay, you have to take clean iron nails. Next, what we have to do, let's see from the activity. So keep it for 20 minutes. Also keep one iron nail for comparison. Okay, so one iron nail we will keep it aside for comparison, and after 20 minutes we will see what happens. Okay, after 20 minutes take out the iron nail from the solution. So after 20 minutes we will take the iron nail from the copper sulfate solution, and what we will see, that the iron nail has turned brown in color. Okay, we will see a brownish color in the iron nail. This is the iron nail that we have taken out from the solution. This is the nail B. Then what we will see, the brownish, after the iron nail becomes brown, what will happen, we will see in the 2 test tubes, the test tubes that we have taken before, we will see that one of the test tube is blue color and the other is faded color. Why has this happened? Because this iron nail, it has taken the color of copper sulfate solution. So the iron nail has become brown in color and the blue color of this copper sulfate has faded. Now this color is blue and this color is a faded color. Means iron has replaced copper. Okay, this is because iron has removed copper from the copper sulfate solution. This was only the copper is been removed, means copper is been taken out from this solution. So this test tube we are seeing it as a faded color. So now here you see this is the equation. FeS plus CuSO4 gives us FeSO4 plus Cu. Now here you see this Fe means iron, we know it. Iron is represented as Fe. plus CuSO4. What will happen when these two are mixed? What we will get? We will get that the removal of the removal of copper. When iron and copper sulfate is iron is dipped in copper sulfate, this copper is been removed from the solution. So this type of reaction is called displacement reaction. Okay, it means a more reactive element will displace a less reactive element. So here iron is the more reactive than copper, means iron is always more reactive than copper. This we can prove from the reactivity series. So for reactivity series I will give you a separate video for that. Okay, since iron is more reactive than copper, therefore what happened in this particular activity, this copper is been removed from the copper surface solution, and what we will get in the product, we have got it as iron sulfate, I mean ferrous sulfate, FeSO4 we have got in the product. And next is the double displacement reaction. Okay, so double displacement reaction, there is exchange of ions in this type of reaction. Okay, so here what will happen, that Na2SO4 plus BaCl2 will give us BaSO4 plus 2NaCl. So here exchange of ions will take place. So from Na2SO4, this Na2 represented as A. Okay, SO4 represented as B. And in A we are giving it positive sign, and in B we are giving negative sign, means. So here in this reaction, this A and this D will switch places. Okay, because this positive ion and this negative ion will again switch places. Hence we can say that in displacement reaction, the ions, positive and negative ions, switch places to form new compounds. Okay, now you look at the example, sodium sulfate and barium chloride. When they are mixed, it will give a white substance which is insoluble in water, and it is formed. This white substance, it is called as precipitate. Okay, this white substance will be barium sulfate in the solid form. Because this white substance is called precipitate and it cannot be soluble in water. Okay, so this in a test tube we will see that white kind of precipitate we will see, and these will be settled down. Okay, so these are the insoluble particles and it is called as the precipitate. Now, so when sodium sulfate and barium chloride is mixed, it will give us barium sulfate. Okay, these when they are mixed, it will give us a solid substance, and that is the precipitate, and this whole process is called precipitation. Okay, so can you tell me how this precipitate is formed? This precipitate is formed by the reaction of sulfate with barium. Okay, since the sulfate is negative means it is anion, and barium it is positive, means it is the cation. So positive and negative, when they are exchanged, means when they combine, they will give us a new compound, that is barium sulfate. It is formed by barium and sulfate. This precipitate is formed by this barium and this sodium chloride. It will be in the soluble form with the solution. So this is how the precipitate is formed by the double displacement reaction method. Now let's move on to the important topic, that is oxidation and reduction. So first we will study on oxidation. So what is oxidation? It is the process of addition of oxygen or removal of hydrogen. So always remember, oxidation is addition of oxygen. So first example, O2 is added to Mg. So it is giving, in addition of oxygen, it is giving us 2MgO. So 2MgO means oxygen is added to Mg in the compound that is formed, it has oxygen in it. So let's say removal of hydrogen. So here 2H2S gas plus O2 gas, it gives us 2S means 2 sulfur solid form plus 2H2O means 2 water. So here what we see that hydrogen is being removed from H2S gas. Next, we will see if a substance gains oxygen during a reaction, it is said to be oxidized. So when a substance gains oxygen during a reaction, it is called oxidized. So here in this reaction, in this simple reaction, we will see that hydrogen will combine with oxygen and also it will give copper. Now you see here that in the product side, this hydrogen that is in the reactant side is gaining oxygen in the product. Okay, so are you understanding this? That hydrogen is gaining oxygen. In the reactant, there was no oxygen with the hydrogen. But in the product, the hydrogen is gaining oxygen atom, one oxygen atom. Next, have a look that if a substance loses oxygen during a reaction, it is said to be reduced. So the substance here is CuO. So this substance is reducing oxygen. In the product, do you see oxygen? No. Means that this oxygen is being reduced. Reduction has taken place. Okay. So now the next definition that I will show you, the next example is on reduction. So what is reduction? It is the process of addition of hydrogen or removal of oxygen. Earlier the example that I have shown was of removal of oxygen. Next, this Br2 plus H2S gives us 2HBr plus S. Here this, what is happening here is this bromine is taking hydrogen from hydrogen sulfide. Okay, means addition of hydrogen is taking place. So next you see Cu plus H2 gives us Cu plus H2O. Here removal is happening. First we have seen addition, now we will see removal. So this is the same example as before. Removal of oxygen is taking place. So this is how reduction takes place. Next you see that one of the reactant is reduced and the other reactant is oxidized. So such type of reaction where one reactant is reduced and one is oxidized, it is called as redox reaction. Okay, or it has also another name, that is oxidation reduction reaction. So here I am writing it as oxidation dash, you will give reduction, oxidation dash reduction reaction. So it has a very simple definition. One reactant is being oxidized and the other is being reduced. Okay, so here I am writing the definition of oxidation reduction reaction. Done. So this is called oxidation reduction reaction or redox reaction. The next topic is on corrosion. So the slow process of conversion of metals into their undesirable compounds due to their reaction with oxygen, water, acids, gases, etc. present in the atmosphere is called corrosion. Examples are rusting of iron, black coating on silver and the green coating on copper. So, the corrosion is a slow process in which metals are converted into undesirable compounds. Means, like the rusting of iron or the black coating on silver, these things happens because of the atmosphere, because of the reaction of the metal with oxygen or any natural phenomena. Then only this corrosion will occur. Okay, next is rancidity. So when fats and oils are oxidized, they become rancid and their smell and taste changes. So when smell and taste of a substance changes, it is called rancidity. Okay. Example is when a chips packet is exposed to air, it results in change in taste and odor. So when we open a chips packet, what will happen? What will happen? The chips packet, if it is exposed for a long time, if you're not eating the chips for a long time, the crispiness will change, the taste and odor will also change. So to stop rancidity, what we have to do is we have to store food in airtight containers and we have to refrigerate it. So rancidity actually it can't be stopped, it can be reduced. Okay, so we can reduce this process by keeping our food in airtight containers and also by refrigerating our food. Okay, so that it is not oxidized, means fats and oils should not be oxidized. This was the last topic for this chapter. With this I conclude. Please like, share and subscribe to my YouTube channel. Thank you for watching this video, and if you want more similar videos like this, you can comment on the comment section below. And